Ladies and gentlemen, with this, we will move on to the next panel discussion, which is Design, Innovate, and Build for a Sustainable Electronics Supply Chain. I'd like to invite the moderator. Ladies and gentlemen, requesting all of you to kindly take your seats as we move on to our next panel discussion, which is Design, Innovate, and Build for a Sustainable Electronics Supply Chain. I'd now like to invite our session chair, Dr. Ravi Bhatkal, who serves as the Managing Director, India for Macdemic Alpha Electronic Solutions, which includes the Alpha Assembly Solutions and Macdemic Enthone businesses. And prior to his current role, he served as the Vice President Energy Technologies at Alpha Assembly Solutions, where he built and scaled a new global business in the alternative energy and energy efficiency value chains. Ladies and gentlemen, can we all put our hands together and let's welcome Dr. Ravi Bhatkal on stage. Thank you. I'd like to invite our next panelist on stage, Dr. Sriram Srinivasan, the CEO of Sirma SGS Technology Limited. And he's been, since 2015, joining the company with a vision of establishing the brand as one among the leaders in the electronic system design and manufacturing space. He has close to 38 years of experience and is a proven business leader. Through his strategic directions and leadership, Sirma's standalone business has grown at a CAGR of over 30% in the last 5 years. Everybody, can we all hear it up? And let's welcome Dr. Sriram Srinivasan on stage. Welcome, sir. And now finally to our last panelist, can I welcome Mr. Jonas Soberg, Associate Director for Global Technical Service and Application Engineering in TM Corporation America. And yes, he is based in Kuala Lumpur, Malaysia, where he provides technical support to key regional and global customers. He has more than 25 years of technical experience in electronics industry, including developing and deploying leading-edge designs and processes for packaging and assembly, managing research and development projects and facilities, and serving as technical advisor to internal external design, development, and manufacturing sites worldwide. He has presented and published numerous papers at industry-leading electronic conferences, magazines, and is appointed as distinguished speaker at SMTAI. Everybody, please put your hands together for Mr. Jonas. And now over to you, Dr. Ravi.
Hello, can you hear me okay? So welcome everybody to the panel on Design, Innovate and Build for a Sustainable Electronics Value Chain. So when Sriram and I spoke, we actually were talking about sustainability in terms of sustainable growth as opposed to sustainability in terms of green. So I think, and we connected afterwards on that as well. So, what we're going to talk about is really covering all of the, since this is a broad topic, covering the links in the value chain that include design, semiconductor fab, packaging, PCB and final assembly, specifically discussing trends in design, R&D, and innovation, equipment and process and materials, and then specific drivers of sustainable development of the value chain, which include strategy, capital, technology, and manufacturing technology, as well as people. So in terms of, this is going to be somewhat of a free-form discussion. Otherwise, I would be told by Sriram that I'm out of syllabus. But we'll talk about really what is the current status in India in these various elements that we talked about, and then cover what each of the panelists thinks is going to be the evolution of the value chains in India over the next 5 years or so, the specific parts of the value chain, and what should our specific focus areas be as we scale over the next 5 years. So with that, maybe I can start with Sriram. If I can ask you to really cover what your view is of the current status in India of the various parts of the value chain in India right now, and specifically if you can cover design, R&D, and innovation in particular, as well as...
Yeah, thanks, Ravi. I think Ravi got really worried about my last session I had. I quipped with Atulji that whatever question he asked me on the panel was out of syllabus. So this time Ravi made sure, he told me 3 times, don't prepare. Don't prepare for anything. It's going to be a freewheeling discussion. So I didn't come prepared. I'm just going to extemporize here. So if I mess up, it's this guy. Okay. Who is, by the way, a very sweet, very close friend for many years now. So I can take that liberty. But coming back to the session and the topic at hand, very interesting. I actually want to kind of acknowledge what was said this morning by several of the speakers, and we had some very eminent speakers this morning. And I think we all understand the value add in the industry today is about 8 to 15%, depending on where you are. I think straight away, if you do box builds and then bring in high-level injection molding and other electromechanicals, I think you can take that number to about 18 to 25%. This is my own experience. You know, others could have slightly different numbers, but that's the ballpark number that I see. But if you get into design, even PCB design and the product design, and you know, convert a concept or an idea that a customer may walk in to your center and then want it converted to a product, I think the value add can go all the way from 30 to 50%, depending on the level of complication. So that's the power of, like the power of compounding, that's the power of you know, design-led manufacturing. I'm assuming that this we would design and also mass manufacture this product. Then I'm talking about, you know, you could take it all the way to 30 to 50%, and that's something that we have to definitely shoot for in the shorter term for this country, because Indians, as a rule, are a cerebral country, cerebral people. I think designing a product, in spite of all the issues that we may have, is not something that's very foreign to us. We can do it. And I think that's precisely what I have been trying to do the last 1 year, set up a design center in Sirma. I think I've completely come out of the EMS part, and I'm doing this experiment. And it's amazing. Because when I used to take this EMS story and go to customers overseas and other places, you know, everyone would say, we're getting our stuff from China and this is cheaper. I have slept very well for the last 30 years because I source from China. I don't know India, and I haven't heard good things about India and manufacturing. The moment I start talking about design, everybody sits up, right? Everybody is interested. They say, let me talk about it. Let's talk about it. So I think we are a natural fit for design-led manufacturing. Having said that, I think if some of you were there on the last panel that I spoke during the Global Investor Summit a few weeks back, I also said, look, what Taiwan, China, India, and all the others are really fighting for is the 30% of the value chain. The remaining 70% squarely still rests with US and its designated allies, which is Europe, Japan, and Korea. And that starts from the core IPs to designing logic, designing memory chips, and then equipment, you know, fabs, foundries. So I think the action really starts for Taiwan, China, and India and others only in the fab and foundry onwards, not even in the materials that go into these, not the equipment that go into this. We all heard of, you know, ASML and others who are European companies which do all the most critical equipments, apart from, say, applied materials, etc. So I think we are really playing in the 30%, but even that 30% is a good $1 to $1.5 trillion worth of value that is sitting there. It's not a mean number. absolutely a massive number to shoot for, and we are at 2.5%, 3%, so we have long, long ways to go to get anywhere near that. So that's quickly my take on where India could pitch. We heard a lot about components being made in India, fantastic, because once you start designing in India, I think what you specify during the design matters, right? And somebody even said this morning that somebody sitting in Bay Area and designing a product will obviously look around and select component makers in those geographies. But somebody sitting in India, if there is PCBs, very good PCBs being made in India, very good capacitors, very good sensors, obviously the choice would be to try them out. Because seeing is believing, and I think you could just take a train or a flight and then visit these companies, see for themselves the process controls, the quality levels, the skills of people who are making this, the commitment from the investors, the entrepreneurs, and then obviously those would get specified. This is, I'm talking without government having to impose tariff and non-tariff barriers. So that's the power of compounding that we can see in 3 to 5 years. If we can consistently work on this. So yeah, I think for me, design-led manufacturing is the first step, and then back it up with component manufacturing in India. I think we heard a lot on this topic this morning, an excellent panel moderated by Josh. So I'm very positive that this would happen. So I will come back for more questions, more answers later. I leave it to Ravi to ask me the right questions.
Thank you, Sriram. Now I'll come to Jonas. Jonas, you're in the material science space, and from your vantage point, where do you see, or how do you see the maturity of the materials and process space in India at the moment compared to, let's say, Malaysia or the other parts of Southeast Asia where the scale is potentially slightly larger, and China as well. And what do you see needs to happen over the next, or what is the current state, and what do you see needs to happen in the next 5 years or so here?
Okay, so I guess you hear me. Yeah, and well, as you see, I'm not from India. I'm Swedish. I lived in Malaysia for the last 25 years. But I think I have a pretty good view of the the industry globally. I think India has come a long way. I started coming here about 15 years ago, working with companies like Nokia, for example, and a lot of people moved out. But now, for the last 5 years, you can tell that what's happening in India is real, and it's really getting traction. I think one of the key things for India is to collaborate with the rest of the world. I think collaboration is key. That goes within the industry, with customers, and with partners. But I think collaboration is the key. I think the challenge here in India, I think I've been in the industry for almost 30 years. And I think from an engineering standpoint, I think India is very high up in the ranks, very educated people. If I compare to, I think the challenge for India compared to China will not be engineering, it will more be on operations. Finding the right people for the factories, I think that's the main challenge. And I just came from China last week, and from an engineering point of view, when I deal with people here in India and in China, I would say competence is very similar. I think the advantage for India is there's no language barrier. So when I come here, it's very easy to communicate with the engineers and with the operators. And I think that's one of the key things for India to promote when it comes to electronic manufacturing.
Thanks, Jonas. Appreciate it. So Sriram, the drivers of sustainable development, which is strategy, capital, technology, and people. Out of that, which are the couple that you think really needs focus, or where India needs to work on to develop it further?
Yeah, I think certainly technology is very critical, and it's a shame that we don't invest a lot in R&D as a country. I have said enough in enough forums on this, so I don't want to keep repeating myself. But having said that, I think in the morning we also heard people saying, can we look at investments? Can we look at JVs? I think the auto component industry was brought up, and I think I have been there for many, many years. I think JVs are probably the best starting point for technology, and then we have to improve on it. Having said that, I think a lot of core IPs are out there available, and there have been a lot of fabulous companies in India, so I think there is talent available in the country as well. So it has to be a combination of both, number one. So on the technology, that's a critical piece that we have to work on. People, I think there was enough said in previous sessions. I would only second that by saying, we have to find ways to skill up and also do it at a certain scale. Because going forward, I think a 50,000 people factory or a 40,000, 30,000 people factory is going to be the norm. If we have to talk about India +1 in 10 years, that Josh spoke of this morning. I think I take that seriously. I think it's absolutely a doable possibility. The way the government is supporting us, the way the industry is gearing up, but we have to find ways to scale up not only the factories but also people skills. And I think somebody spoke of ITIs being supported by the Tata Group for upgrading. I think those are extremely important and timely interventions. I think we can continue to do that and scale up that part of it. I think people will be a critical piece, especially this morning we heard if we have to do components in this country at scale, we need a lot of people and I think that's a great advantage for India because we have skillable people and we have our average median age is 28 or 29, so we have a lot of people needing work. So great chance for this country to do that. So I would say technology and people. I think capital is available today compared to say 10 years back, 15 years back. Much more easier now today compared to the past. So I wouldn't worry so much on that. But yeah, the capital turnover ratios, some of the components could be 1:1. That's always a challenge. So given our interest rates, etc. But I think we will have government supporting us there, I would assume.
So same question to you, Jonas, in terms of the specific drivers being strategy, capital, technology, and that includes core technology, R&D, and manufacturing technology as well. And then people. What do you see from your vantage point as, what areas need development or additional work here?
No, I mean, I can just echo what you said. I mean, technology and people is key, and I probably would say people is the most important. I think that's how we can grow. But technology as well, even though we're a small company compared to McDermott for sure, we don't do R&D in India today, but I wouldn't rule it out that we will do it in the future. And I think technology comes in many ways. And I think technology and people kind of come together. And I think as a material supplier, I think our goal and our job is to manage the customer expectations. We don't want to promise or overpromise things. And I think that's where technology and people come together. It's managing the customer expectations. Because as a supplier, or I'd like to say a partner, we don't want to waste the customer's time, and we don't want to waste our time. So it's better to manage the expectations from the beginning. If that starts like a negative point, so be it, but it's better to manage the expectations from the beginning. Yeah.
So Sriram, one question is regarding equipment, right? When we, one of the things that we really see as a gap is that almost all equipment today is imported here, and the question is, what would it take to really build a domestic equipment manufacturing, design and manufacturing setup and industry? So I wanted you to address that.
With respect to equipment? Or?
Yeah, with respect to equipment in particular.
I don't know. Very honestly, I don't know the answer to the question because that's a space that I have not been exposed to. But I think I don't see any need. See, even if you take the value chain, equipment comes in at about 5% of the total. So I don't see a pressing need immediately to indigenize the equipment. Given the opportunity space that we are talking about, I think we should be able to afford and to develop something what ASML does today to even reproduce 20% of it is going to take some doing, right? If I don't know how many people know this, I think Intel in the early 2000s sunk more than $1 billion in trying to make extreme UV, and they abandoned it after 4 years of R&D. And the great thing is ASML continued that R&D, but Intel abandoned it. And see where ASML. So it's not an easy space to get into and become an expert. I think that can wait. In my opinion, that can wait. I think there are more pressing things for our country to do. So I think we should do what we are good at. I'm cheating a little bit on the answer, but.
So if you were to select maybe the top 3 or 4 things to focus on, what would you say?
I honestly, what I said already, design-led manufacturing, and then skilling up people at scale, and then finding how to develop quickly technology to get into component manufacturing. Like a lot of people before me said, the EMS piece we have figured out, finally, after 15 years. And I think we are getting good at it because the governments are supporting us. But I think the component piece is what we have to figure out, and I think if we can do that, if I sit here after 5 years and say component piece is something we have again figured out, like the EMS, I think I'd be very happy. So that's where, and I think there's no dearth of opportunity. If I'm really tempted to leave this panel with a perspective that actually kind of was wonderful for me to look at. See, there was a article, I think, in Economic Times, a Business Standard, which said the penetration of cars per 1,000 people in India, Delhi is 41. There are 41 cars for every 1,000 people. Rest of India is 17. And all the other countries are way above 100, right? So even if the entire country moved from 17 to Delhi's today's average of 41, for electronics, if I take 20% of the car as electronics, that's a $23 billion opportunity that we are looking at. So we don't need to build equipment at all. We can afford to buy equipment from overseas, so long as there are no sanctions, from selling equipment to India. I think we should focus on manufacturing and design-led manufacturing and making the components, as many components as possible in India.
And that,
And leverage our people strength, yeah.
so both semiconductor and non-semiconductor components.
Absolutely. I completely agree with what Vinod said today, the PEP scam and Delta. I think I'm totally with it. And I'm getting a signal from Raju that the minister is here, and so he wants me to get out of here. So.
Those of you who are attending the session on Design, Innovate and Build for a Sustainable Electronic Supply Chain can please remain here. We will resume the session now. Thank you. Over to you, Dr. Ravi.
Another 5 minutes.
Yes, sir, please do.
Thank you. So after that exciting talk, he charges you up, right? Yeah. I wanted to ask specifically, Sriram, how do you see the, huh? Oh, no, one more. Okay. Your perspective, actually, in terms of semiconductor packaging in particular, how do you see that evolving over the next 5 years here? Because there's about at least eight OSATs that I can see that have announced. How do you see that sort of coming to fruition and moving forward?
Yeah, I think 2-3 years back we were decrying the need for wafer packaging. We said we don't even have a decent wafer packaging in this country. Why are we talking about setting up foundries and fabs and things like that? Now I think that moment is upon us. I think we have more than enough announcements on the OSATs. Like the minister said, at least if 70% of them come to fruition, I think we have a great chance. My only concern in all these announcements is, where are the wafers coming from? Where will the wafers come from? Do they have arrangements for wafers to be supplied to these OSATs? And if so, then we have a great chance. But OSAT is not the easiest of businesses. It's an extremely difficult business because you have to constantly feed the machines. The margins are very, very thin, which means your plant utilization factors have to be at a very high level, which won't happen in India with India supplies, but you have to have buyback arrangements, etc., with whoever is selling you the technology. So if they have figured out all that before they are announcing these OSATs, Godspeed to them. I think that is something that India definitely needs and eventually will need also. So it's timely in that sense, but I still have my concerns.
Jonas, from your vantage point, your learnings from Southeast Asia in particular, for example, what would you, because Southeast Asia has a good mix of assembly and packaging as well. And so what are the learnings that you can convey from your experience there?
I mean, one of the key things, and I'm a very simple person, so I don't want to complicate things. So if you look at an OSAT, what's the difference with an EMS? Is Foxconn, are they an OSAT or an EMS? They're doing packaging already. The same with Flex and Jabil, and then you compare like with Amcor and USI and these guys. So I think when you talk about semiconductor, fab is one thing. It's very complicated. But if you look at building packages, most of the equipment that you will see on the production floor will come from ASM and similar companies. The difference on the equipment will be that it's for a clean room environment. So instead of having a white machine, it's a stainless steel machine. So I think the thing is, I think India is very well equipped with EMS. If you talk about semiconductor, I would not overcomplicate things. The main difference, and I mean, as a material supplier, and with you, I mean, with McDermott as well, we supply materials to semiconductor and to EMS. Yes, there are differences, no question about it. But if you look at the equipment, it's still soldering materials that we supply. So I think the key thing that's going to be different when India moves into semiconductor is cleanliness. and handling a clean room environment, because that's something you have to learn. It's not, I mean, you can read about it, but you have to face it. But I think India is well equipped for doing some of the semiconductor. I would not overcomplicate things. Yes, from a fab point of view, it will take a longer time. No question about it. Okay.
Thank you. I think we're almost out of time. Perhaps what I can, maybe I'll open it up to questions if that's okay to the audience, because I've been asking all the questions. So any questions from anyone in the audience, please, please ask. No questions? Yeah.
Jonas said the operation challenges between India and China. So if you're told you have to play the catch-up game or go ahead of the game. So how do we overcome these operational challenges? What are the way? It's just training in the factory can do this small thing, or from your experience, how did China get this operational challenge done and how can we get it done?
I think it all comes with experience, and I think it very much boils down to the management have to make sure that the operators is getting the right training and also the right experience. But I think training is key. I think with China, they've been doing this kind of manufacturing for like 30 years now. But I think India will get there, but I think it's training, and I think India can sort it out internally. I don't think we need to bring in much foreign people, that the competence is here. So it's just giving the operators and the workers the time to get educated in what they're doing, and making sure they're getting the training from the beginning, because I think it's first, how should I put it? What you learn first is what you will remember. So making sure that they learn it from the beginning and in the right way.
Thank you.
Thank you. Thanks, Jonas. Yeah, sure.
Hey, Ravi, want to go back to that question on actually making the equipment in India. So I agree you can't make advanced lithography and all of that. These guys have invested billions of dollars in R&D and all that. But if you just kind of do the math, right? Let's say India does 5 fabs over the next few years. Maybe it does 5 fabs, 10 OSATs, something like that, right? A single fab has like $5 billion of investment, 3.5 billion is probably capex. So you're looking at maybe $15 billion in just equipment that India is writing checks for. Government is subsidizing half of that. So why not just find a way to make some of that? Even if it's like 20% of that, 15 billion that comes to India, it's like a $3 billion industry that you're kickstarting of equipment being made in India to begin with, right? Why give that away by free checks to somebody else, right? I mean, question is to Sriram, because he challenged the notion that you can't make equipment in India.
No, I didn't say we can't make it, but it'll take time to figure out. Yeah, I mean, the math is definitely tempting to give a straightforward answer to your question. The math is definitely tempting. There's going to be a lot of government money that's also going to be involved in terms of incentives. But how are you going to do it without some JV being set up, some seed technology coming in at least before you can embark on something like that? So I don't know. I mean, if that is priority for us, that's why I kind of said if there are no sanctions. So yeah, necessity is the mother of invention. If somebody, like what's happening in China today, that you can't get this machine, somebody puts a stop to it, then I'm very sure we as a country will figure it out and put that investment and make that equipment. But today, if it's available and it can get you jump started on something, why not just go and invest the money? It's after all upfront investment, and then you can figure it out going forward as you start working with those machines. as you, the next generation of machines, at least you can promise yourself that we will not import it, we will make it only in India. But for me at least, it's not, equipment is not priority yet. There are other priorities that I would rather go after. Yeah.
So I'll probably add to that a little bit. If you look at both Applied Materials and Lam, Applied has already started sourcing components in India. So they are developing a supply chain in India, an ecosystem. They're building an ecosystem in India. They have their equipment research facility here now that they have kickstarted. And the same thing with Lam. So I think that it will be an evolution over time. I wouldn't put it past them to actually ultimately build the equipment here. If you look at who's controlling the market, there's 3 huge players, 4 if you include ASML. It's Applied, it's Lam, it's TEL, Tokyo Electron, and ASML, and a few others, but they're the big ones. So getting them here and building an ecosystem, equipment, component design, equipment design, and high precision manufacturing ecosystem, I think it'll go a very long way because those skill sets are translatable. If you look at Boeing, for example, Boeing is already sourcing over $1 billion worth of subsystems components here. They have a full ecosystem. Same thing with Lockheed Martin. And so you are seeing very sophisticated manufacturing ecosystem emerge. No reason it cannot be done. It's just a matter of pulling the things together, to be honest.
Yeah, no, I just echo what you said, Dr. Ravi. I used to be with an EMS company before, and I think once the EMS or the OSATs start pushing for equipment made in India, that's what's going to drive it. But it has to be someone asking for it. As long as the prices are the same and delivery times are okay, it's not going to happen. But once the delivery times, even if the price is the same, obviously it will be shorter delivery times in India. And I think it's the EMSs and the OSATs that will push for equipment manufacturing here. After being at an EMS, I know how they work, so.
Sorry, Rajuji.
Just wanted to ask a very basic question, because I hear 2 things, because I keep hearing more in the industry than, so I hear that, we are very good at design, we've got, good engineers, we are innovative, we've got jugaad, right? We have frugal technology, etc., etc. But we don't seem to have enough of design or innovation still. And is it because we are not wanting to pay for it, or is it because we are not wanting to invest in it? Because I think these are things which you have to start, investing in. And then over the years, you reap the benefits. It is, like R&D, something like R&D. So, do you think it is because of our culture that we have this issue with design and innovation, or what is it? Just a thought, which I'm not very clear about why we are not able to, because we have the best engineers, right?
You want to take that, or? Go first and then I'll. Yeah, so, as far as chip design, for example, is concerned, we are doing probably 20-25% of global design is done here. So that's a big number, actually. So, but that is one piece of the entire value chain. If you look at design overall, there are many, many different aspects to it along the value chain, right? Just looking at electronics. If you start from the end, it's industrial design, it's designing the final product, it is working your way back into the subsystems design and the design of the individual components, and including PCBs and so on and so forth. I think I would say that there is definitely a lot of design going on here. Um, Probably needs to be more, you can separate that into multinational companies and domestic companies. Most of the design that you see, chip design, is done by multinational companies. There are, Incor, who's going to be speaking tomorrow, that's a domestic, company that has come up from in Chennai. It's all indigenous, right? But those need to increase, clearly. It's the more the indigenous capability that needs to increase, and that does require investment. You can talk about startup investments, or you can talk about domestic companies investing significantly in the design capability and the R&D capability. In India, R&D as a percent of sales is still fairly low. And if you look at semiconductor and electronics in general, the R&D investment as a percent of sales is quite large in general, right? Whether you consider finished products or you consider all the way up to semiconductors. In fact, that is why Sriram is talking about 70% of value is in the design and IP, because that's where a lot of the focus is. And I don't disagree at all that given the fit between the Indian engineering capability and design capability and that value that is available, it's absolutely a good target to go after. Because as he said, he's right, 70% of the value globally is locked in that. So I think we are set. We can close. Thank you everyone for being patient, and thanks Rajuji for inviting us and having us here. Thank you. And thanks to the panelists for being patient.
Thank you, gentlemen, for that session. Can I ask Raju sir to please come forward? Vinod sir, can I ask both of you to please come forward and give away the... Yes. Can I request Mr. Vinod Sharma to please come forward and give away the mementos? Thank you very much, Mr. Jonu Sober. Well, ladies and gentlemen, let's hear it up with a round of applause for our moderator, Dr. Ravi Bhatkal, and Dr. Sriram Srinivasan. Thank you very much. Thank you very much, gentlemen, once again. And with this, ladies and gentlemen, we've come towards the end of day one. We request all of you to please go ahead and visit the stalls, and we will see you all tomorrow. All right, so tea is out outside just behind. Please go ahead and have some tea. And the exhibition is open. Please go ahead and visit the stalls. And we'll see you all tomorrow for the opening session at 10 a.m. Thank you.